Hello, this is ABA International Academy. We are continuing with our series of differentiation, and today we are going to be looking at how we can find the derivative of a function by using what we call the chain rule. But before we get started, this is just a quick reminder that you can hire professional tutors from our organization for online and in-person tutoring. We are based in Hong Kong and all over Africa. Also, you can connect with us by using the WhatsApp numbers displayed on your screen. We're tutoring Cambridge student and IB student, all levels and all subjects. Thank you and welcome to today's session. So let's get started with the chain rule. Before chain rule, I want to remind you of something that you learned when you're doing function, something that we call composite function. Composite function. Composite function is simply when you write one function in another. You combine two functions together. You plug one function into another function. For example, let's say you have g of x, which is x raised to the 7th power, and then you have another function f of x, which is raised to the, which is just 2x squared. Let me just say x squared minus 3. We can composite these two functions by writing f of x as an input in g of x, and this is going to look like this: g f of x. We are plugging f of x into g of x, so I'm using the function f of x function as the input. So this is going to look like x squared minus 3 raised to the 7th power. I'm replacing this x here with x squared minus 3. I can also do the other way around. I can do f g of x, and this time I'm going to write g of x as the input in the function of x. So g of x is this one here. G of x is this here, so I'm going to just plug in here. In the place of x, I'm going to plug x squared. So this is going, in the place of x, I'm going to plug in x to the 7th power, bracket squared minus 3. So these two functions are called composite functions. So the chain rule is going to help us to know how to deal with this composite function. If you want to find derivative of this function, or the derivative of the second composite function, how do we do that? We're going to be using the chain rule. Now the chain rule states this. It states that the chain rule states that if y is a function of u, if y is a function of u and u is a function of x, then the dy dx derivative, or the dy dx, can be calculated by taking dy over du times du over dx. You can tell here that this du and du will cancel here, and then we'll remain with dy dx, dy over dx, which is our expected result. That's what we're trying to find, dy over dx. Okay, I can explain this. So if you have y equals to u, and then you have u as a function of x, you can actually derive this. You can find the derivative of y with respect to u, and what you get here is dy. You're getting dy here over du. The same thing here, you're going to get du over dx. That's what you're trying to do. So when we multiply these two together, we're going to end up with dy over dx. Now let's take a look at the examples. Okay, let me use the first one, this function here, the first function here. This function, it's okay, x squared minus 3 bracket raised to the 7th power. So the first part is going to be to really recognize which one is u function and which one is which one is y function and which one is u function here. Like we have to select, you have to let one function be equals to u, because these are two functions combined together. If you remember this, x squared minus 3, this came from f of x, and this 7 here, the result of this function. So this is what you're going to do. We can say that because remember, y has to be the function of u and u has to be a function of x. Y has to be a function of u and u has to be a function of x. Simple. It means you're going to have y equals to u. We need to have something like this, y equals to u, and also need to have we need to have something which is y equals to u, and we need to have another function u equals to x. So you can tell here now, because we have x squared minus 3, we can call this one is u. So you can say let u equals to x squared minus 3. Now we can plug in here, because this function y equals to this. Now we can replace x squared minus 3 with u, and this function is going to be y equals to u power 7. Okay, let me write this. Now we have two functions. This first function is this one, u equals to x squared minus 3, and the second function is y equals to u raised to the 7th power. Now I can take a derivative. I'm going to differentiate u with respect to x. So du with respect to x here is going to be 2 times 1 x power 2 minus 1. I hope you remember this. And the derivative of negative 3 is just 0, because we said the derivative of a constant number is 0. And for the second function here, dy over du equals to 7u power 6. 7u power 6. I hope you know how to do that. You can visit the other video where I explained how to find the derivative of a function if you are still struggling to find the derivative of a function. Now we are going to put these two together. We're going to find the product of du over dx times dy and du, and that's going to be our answer. So by chain rule, we can say now dy over dx equals to du over dx times dy over du. You can just plug in du over dx is 2x, and then times dy over du. dy over du is 7u per 6. 7u per 6. When you do this, when you multiply this together, you're getting 14x u power 6. Now you can go ahead and replace u. Remember that just say u, but u equals to x squared minus 3. So I can actually replace this u here with x squared minus 3, and that will give me this value, that dy over dx should be 14x times x squared minus 6 raised to the 6th power, and this should be the answer. That should be the answer. Okay, let's take a look at another example. Find dy over dx when y equals to square root of 4 minus 3x. Find dy over dx when y equals to square root of 4 minus 3x. So the trick here is just going to be to find what is u and then write this function in terms of y equals to u, and then you're going to find the derivative of each separate function. This is what I mean. Solution here, y equals to square root of 4 minus 3x. So we're going to say u equals to 4 minus 3x, and this is going to be our first function, and then our second function here, since you are replacing u with 4 minus 3x, that means y now is going to be square root of u. We are replacing the expression inside the radical sign with u, so y is square root of u now. Then we can find the derivative of u with respect to x, and then the derivative of y with respect to u, and then we can multiply those two and find the right answer. So du now with respect to x, it should be negative 3 times 1 should be the answer, which is just negative 3. On the other hand, dy with respect to u, the first trick here is actually to get rid of this radical sign here. So this y square root of u is equivalent to u raised 1/2. So the derivative equals to 1/2 now, times 1, then times u power 1/2 minus 1. So dy over du should equal 1/2 u raised to negative 1/2. Now by using chain rule, dy over du must be equals to du over dx times dy over du. Now just going to plug in our numbers. Du over dx is negative 3 times 1/2 u power negative 1/2. The next step is to replace u with the value that we set it equal to in the beginning. So in the beginning we said u equals to, we set it equals to 4 minus 3x. Write it here. We said that u equals to 4 minus 3x. 4 minus 3x. So we're replacing it back, we're putting it back. But before I do that, I want to multiply these two. Negative 3 times 1/2. Negative 3 times 1/2 is negative 3 over 2. And then u is replaced with 4 minus 3x power negative 1/2. This should be the right answer. That should be the right answer. There is a way of rewriting that. If you want to write that, you can go ahead. If you don't want to have the negative number, you can go ahead and rewrite it and actually put back the square root sign. This will be like this. Should be negative 3 over 2 square root of 4 minus 3x. Don't forget to put the negative. So either this one is correct or this one is correct. I mean, this one is, both of these numbers, of these answers are correct. This one is correct, and also this one here is correct. Okay, let's take a look at another example, more complicated one this time. Example 3. In example 3, let's find dy dx when y equals to 2 over 3x squared plus 1 bracket power 4. Hope you can see that. So first I would like to start by rewriting this equation. We can write this as y equals to 2 times 3x squared plus 1 raised to negative 4. Remember, when you're reciprocating, you have to change the sign of the exponent. It was positive and now it is negative. Then from here I'm going to let that u equals to the number inside the bracket, the expression inside the bracket. So u equals to 3x squared plus 1. This is going to be my first expression, my first equation, and the second one is going to be 2y. Now y equals to 2. This expression is replaced by u, so it's going to be u power negative 4. Let me write this. U power negative 4. Now we can take the derivative. So du with respect to x, derivative of u with respect to x, should be 3 times 2 x raised to 2 minus 1, and this should be 6x, should be 6x, and then dy with respect to u equals to 2 times negative 4 times u raised to negative 4 minus 1. So this should be negative 8 u raised to negative 5. Then by chain rule, we have to multiply the two product. The chain rule, dy over dx is the result of du dx times dy over du. This is how we find the product. So you just have to plug in. du over dx is 6x, then times dy over du, dy over du. dy is negative 8u per negative 5. Go ahead and simplify this more. You multiply, so 6 times negative 8 is negative 48x, then u raised to negative 5. You can go ahead and plug in now u. We said u, remember this data, u equals to 3x squared plus 1. So dy dx is going to be negative 48x times 3x squared plus 1 raised to negative 5. If you don't want to deal with negative numbers, there is a way of rewriting this. If you don't want to deal with negative exponent, there is a way of rewriting this. You can just reciprocate it and put negative 48x over 3x squared plus 1 bracket power positive 5. This one also works. Again, the first one is correct, the second one is also correct. Okay, and also don't forget the negative. Number 4 now. This is number 4. It is important that you practice. Make sure you're practicing more to understand how the chain rule works. So we'll soon start solving some of the past paper questions here. I'll be solving here to show you how to tackle some of the questions, but we'll do that after completing the first part of differentiation. So example number 4, find dy dx when y equals to square root of 5 plus 3x cubed. So solution, start by rewriting the equation or the function that y equals to the square root of 5 plus 3x squared. Then we can say u equals to 5 plus 3x squared. Also note this, that this function here can be written as y equals to 5 plus 3x squared raised to 1/2. We can write it this way. So this is going to be our first equation here. In another equation now, this y now is going to be replaced by this u value. So y is going to be u raised to 1/2. Remember, we are replacing the expression inside the radical sign by u. So this is becoming y equals to square root of u. So square root of u is equivalent to square root of u is equivalent to u power 1/2. Now we are going to find derivative of du with respect to x. The first number is 5, so the derivative of any constant number is 0. The second term is 3x squared, so we're going to do 3 times 2 times x power 2 minus 1, and this is going to give us the following answer. 3 times 2 is 6, x. 2 minus 1 is 1. On the other hand, we have dy, dy du equals to 1/2 u, and then 1/2 minus 1, so dy over du should equal to 1/2 u negative 1/2. Now we're going to apply the chain rule. We're going to apply the chain rule. By the chain rule, now we're going to do this, different color. That's a dy over dx equals to du equals to du, okay, equals to du over dx times dy over du. Remember, this equals to this, and this one equals to this. So plugging in the numbers, should give us the following. Du dx is 6x, so 6x 6x times 1/2 u power negative 1/2. Go ahead and simplify this further. 6 times 1/2 is 3, so 3x, then u raised to negative 1/2, 3x u raised to negative 1/2. We're going to replace u with our expression. Remember, u, we said u equals to 5 plus 3x squared. 5 plus 3x squared. 5 plus 3x squared. So I can say that my dy over dx equals to 3x bracket 5 plus 3x squared bracket times negative 1/2. This should give you the answer. This should be the answer. You can leave it as it is, or you can actually write it. I'm not going to do that. Again, let me just give you homework questions here for you to practice. So make sure you're using chain rule to find these answers. So try this. And this one. You also want to try this one. So make sure you are. Number 3, I want you to try this. So if you have any problem with these questions, you can actually let me know in the comment section, and then I should be able to help you. Next time we're going to be looking at the second derivative. But before that, we're going to be looking how to find the gradient of the tangent using differentiation. You're going to be looking at a specific point Remember, when you're differentiating, we're getting the general gradient function. We can use that gradient function to find the gradient at any given point, So thank you so much for joining me today. Please invite a friend to subscribe to this YouTube channel and get tuned in for more content that we'll be sharing here. Also, don't forget to make use of this information here. You can hire a personal tutor. You can hire a personal tutor for any subject, not just mathematics, for any subject, including French, Arabic, Swahili, and many other subjects. Thank you and have a good time.